I'm sure that all of you have Wireshark in your laptops. So we're going to open this Wireshark, and then I will go through what we have to do. So I don't have to read everything. The first thing we need to do, I will give you a few minutes to open this. So when you open, the home will not appear like this. I have to clean up mine so I can start the class. We have to configure the right appearance. Okay, so the Wireshark should look something like this. Once we're here, we can start the class. I'm waiting like 1 minute to get to this stage. So on the Wireshark, yes, on your real laptop. Anybody opened it? Okay, so if you've opened it, what I want to see at the bottom, look at the packets. For me to know you have the real file, we want to have a total of 98,024 packets. So 9,200 and let's see. Okay, 9,824. Okay, so what we are doing today, in real life, you'll be given something like this, and my job as a market analyst is to look at this data and make a meaning out of it. And you can explain what is happening to the company that hired you to look at this data. Faisal, please. Are you all here with me so we can start? All right, so when anybody sees this kind of capture, it's overwhelming because there are too many things to look at. And we can't go and look at every single package sequentially. That will take us a long time. This is even a small capture. Imagine having like gigabytes worth of data. So we can't do this. We can't go and say, okay, this is the first line, second line, third line. What we do is to set a profile. And to set a profile, we are going to apply different filters to jump into certain areas. So the first thing we want to do is to reduce what we see on the screen. So the starting point, because if you have this, you may not know where to start from. So the first thing we do, we go to edit. So from edit, we go to preferences at the bottom. And then under preference at the bottom, we go to appearance. Under appearance, we click on the columns. And from the columns, we can decide what appears on our screen. We can control what parameters we want to display. So this is an important area to help us filter and make our work easier for us. So from the material you have today, the first thing you want to do is to go to the columns and only keep 4 things. So what they want is the time, the source address, destination address, and information. Which means we can go to the column and do those ones and also add new things. So follow this one, and for step 3, you need to add source port that says source port unresolved, destination port unresolved. So we are going to add 2 more filters. So if I come back here, you can see on my column side, if you look to the bottom, you will see a small plus. So if I click on the small plus here, it opens a new field for me. In that new field, if I click on the number twice, it gives me a drop down. So what we want is to include a source unresolved. So I have to go and find the source unresolved. So see the one that says not resolved, unresolved. So the one that says source port unresolved. So if I click on this, now I have the source port unresolved. I'll come back here to the new column, double click on it and write it source. Let me see what is written there. So source port, okay. So it's source port. So this is how we can add. And once we add, it appears on the screen for us to see. Did anybody add this one? Okay. So the same way we add, we can still always remove things. We as malware engineers, we can't just use Wireshark the way people use Wireshark. We customize what we want to see that will reduce from having 9,000 things to just few important things. The next one we want to add, so look here, destination port unresolved. The same method to add this. So again, we click the plus and then double click on the number and we select destination port unresolved. Here we go. And after that, come here. And then you click. So now we've added the two ports, source port and destination port unresolved. So the next thing we want to do, let me see what they want again. So the next thing we want to do, we can check if they are working. Okay, so they only want the time, the source address, which is IP, destination address for IP, info. So in my own case, look here, I have the time, I have the source address, so I need to remove protocol. So I simply uncheck protocol. Because I've done this several times, my profile looks different, but I add too many things, I remove things. And by the end of today, we're going to have different methods to still add to the column that will make our search a lot easier and more professional. So now I have the 5, if I'm correct. So I have the time, the source, destination, and there's something missing. Okay, let me try. So click apply and click OK. Now, look at our screen now. It's much reduced. Anybody have something like this? You can scroll. So, when we have this, what I like to do is to align every column to the left. So, let's see this one here. I can try to make it so I can see better. Okay. I don't want this one to be this big. So look at the info field, it's too big. I don't want to filter you. Okay, so with what I mostly do is to align every, because sometimes you may have big gap between different parameters. So you can right click on it and align to the left and shift it to the correct destination. Right now, we have the 5 ones that we need to continue. Okay, so the first thing, as you can see, that you may have, in this case, I don't know if it's the same one we're looking at, but look here, the first IP address is 10.7.10.101. Do you all have the same? So 10.7.17. So mine is different. I have 10.7.10.101. Who has 17.101? Or do you have the same 10.10.101? Just like me? Yes. Okay, that's fine. So the material is slightly different for the IP addresses. So the first thing we want to do is to try a filter. And the first filter is to do HTTP request, which means what are the communications being sent to the web browser. So the filter, for us to use filter, because I've told you that if you have 98,000 packets, I don't want to look at all these packets. It will confuse me. So the only way for me to succeed is to use filter, to only see what is important. And again, in this case, somebody has captured the entire network. People make a mistake of saying, let's say you're looking for malware, and they only capture one particular protocol. That is not correct, because sometimes it's telling you that there's a problem here, but because you capture only one protocol, you don't see those problems. Instead, capture like this when you have all the protocols and all the problems. It may be bulky and big, but to help you to understand in case of a problem. So let's go to the filter, this area here, and do HTTP dot, and this is like user-friendly. If you click dot, it gives you the options, and I can say request, and you see that it gives you the option for the HTTP request. If the color changes to green, it means you have the right parameters, and I just hit enter. So by doing this, out of my 98,000 files, I only have 5 files displayed, which means my job is a lot easier. Anybody have this? You don't have it? No. Okay, so students, you see that with filter, we don't need to look at the entire 98,000 files. We reduced only 5 files. And here, we can analyze the 5 files. So what do we see? So because during our profile, we wanted to see the source IP, destination IP address, and the information, because this information field will tell us a lot about the file. And if I scroll to the right, we also have the source port and destination port. Okay, what we will do, just click on the first packet. So click on the first packet. Once we go to the first packet, my favorite profile is to have the one on the left side and the packet diagram. So most of my work today will be focused on this one on the left. Who does not have the thread like this? The packet, this one, and that one.
I have text, not diagram.
So you can change it. So go back to preferences. Yes. And you can now select, so on the left, so see packet diagram, this one now. And then this one. So you can always make, personally, I don't say it's correct, but I always use this packet diagram because I can see, we talked about the 4 layers, what is happening everywhere, all those, I can see them here in a format that makes me, or look easier for me. But most of my job today would be on this side. Because here again, I'm coming, here again, you can see the 4 layers that we have in TCP IP. And you can see the actual bits of ones and zeros. You can see the Ethernet layer, which means the MAC address of the source and destination, and also the name of the device itself. This is the one with Ethernet. For example, Hewlett Packard Bell. So maybe the person put the computer name. If somebody put a name like Al Hanouf, then the name will appear here. But we can find a way to find the person's name again going forward. And then we'll have the, I don't care about this one for now because you already know IP and source destination is fine. And then we'll have TCP. If it's UDP, we'll have UDP. And we can go there and see some things. And finally, the protocol we are looking at. So because we filtered HTTP, if I click on this, I can learn a lot about what is happening to this file. Alright, so because of time, I have to walk now. So students, filters is our friend. Not to look at the whole data and try to make a meaning. So what we want to do, we can look at the data, sorry. So let me show you something. So on this particular data, I selected the first one. And once I select it, I can come here to the protocol, HTTP, and then what do you see, students? Look at the host name. So I just expanded the HTTP, and then you can see at the bottom that says host name. Anybody have that? Do you have the host? Can you see the host? So what's the name of the host? blog.eskill.com. How can I make my filter better? Because I found one of the host name, it means I can now use this. So instead of me going back to the preferences to go and add a new column, I simply right click on this. So when I right click on the host name, I go and say apply as a column. So look at the magic now. So I applied as a column, and if I scroll up, what do you see? It has resolved all these devices to the exact host name. So we don't need to always go to the preferences to put the columns. Our skills are to find, so let's say I want to know the name of every machine. From this host, now I add a filter that automatically filters for host name. And if I click like this, you can see the filter. So the filter is http.host equal, and because we left it blank, it puts the correct name for every single host. This method, it means that we converted each of these machines to the name of the host name of the machine. So we've added a new column without going to manually add it. So this is how we can find the host name of every machine. If they call the host name, for example, Safa, then we can see here Safa, PC, and stuff like that. Okay, let's move on. So the next filter we want to do is to look out for some server names. So look here, for task number 5, we want to find the name of the server. And there are two methods. If you have an old Wireshark or version 2 point something, then we can use the SSL. If you have a more recent Wireshark like version 3.3.4, we can use TLS. Both of the commands are working. So back to my filter, I go and I click on the small X here to go back to the default settings. Remember, we've added a column, right, that gives us the host name. So whenever there's a host name, it will appear automatically. The next stage, I want to scroll to the top again, and now we want to filter what is the name of the server. So ssl.handshake. So handshake.type. So ssl.handshake.type equal 1. Okay, so this next filter is trying to see whenever the client and server exchange information. So if we filter it, what do you see? You see all the hello message. Why did we use 1? 1 is because of the hello message. We have different message, and each message has a number code. So most of the one you see is from the client. So what we are filtering is for the client. If I want to filter for the server, I will use 11. And I can see the difference. And in most cases, students, if you look here, you see client hello, right? If you find anything outside of client hello, it's malicious. So if we filter for client and we see anything that's not like, if you see like a get something, it's malicious. And we can stop there and examine that path when it's like that. So from here, we can see some websites like Event, Data Microsoft, Bing.com, and all those ones. So let's go and see the server name being used for each of them. And we can make a new column again that can filter all the server names. So click on the first one you see, or anyone you see at all. So let me just take any one of these ones. So I click on the first one. It doesn't matter which one you click right now. So if you click on the first one, what do you see at the bottom now, students? You see that instead of HTTP, we have the TLS or SSL. So if I open this, I will now have the version of the TLS. And again, you can see that it's a handshake protocol between the client and server to exchange and share certificates. Because of security, for you to establish a secure connection, you must do the three-way handshake and then exchange certificates and all those different things. That's the protocol we want to filter and know which server, in case somebody install a fake server that can steal your data, we can know from here. So I open the protocol again, and then you can see if I go and make the server handshake protocol again, now we have multiple things, and you can see the random value. I remember in L5, I may have talked about the three-way handshake, like in network security, where I said we have different methods. For example, asymmetric encryption. When you have a public key, private key, you have a nonce, a random number. This is the random number being used. And now we see the number. We can simply copy this number and go and convert to the real, maybe X value, whatever. But that's not the point. Our focus is to find the server names. So if I scroll down, look at this extension that says server name len 37. So if I open this one, are you there with me? So if I open, remember there are lots of extensions. We need to know where we want to find server name. So if I open that one, I have one that says server name indication extension. Again, I open that one. And then I have the 4 parameters. So look here. Now, server name in my case is equal to geo-pro.something. Anybody there with me? So if you did not select the first packet, you may have a different server name. Once we are here, we can then apply our filter to give us our server name. Before I do that, students, look like this, right? We don't have a column for server name. So now we can translate this to help us. So if I right click on server name and sample, I say apply as column. In less than 10 seconds, if I come back here, what do we have? All the names of the servers that were used for every single device is now showing in our column. This way, we can see what servers were being visited and what was used to exchange information. So if something is malicious, we can see from here. So filtering is the secret to analyzing malicious activities. We can't just look at the whole packet and know what we want. Now, we get only 152 packets that did the server exchange, and we know the names of every server. This is important information, to know the name of the server, because if a server is bad, if somebody install a fake server, you can see from the name. They can't hide from Wireshark. Okay, anybody got the servers? So you can see that on the left-hand side, we can manipulate Wireshark to help us, give us lots of details about our packet. Since we're already here, I want to do one more thing. I will just copy what I did previously because I'm lazy. And I want to just close my filter. The small x, close the filter. And what I will do, I will make a different filter now. Instead of 1, the message, the code I use now is 11. And you can see the difference. So, when I use 11, what is the difference now? Previously, it was client hello. Now, the certificate. And within a certificate is something that validates a web server that makes us trust a website. How can we know the certificates and confirm if they are valid or not? This is the way to apply the filter, and we can go and check all the certificates that are there, and we'll see which one is working and fine. Again, similar to the client, if you find anything strange here, we know it's malicious activities. So let's look at the server certificate. So our focus now is not on the name of the server again, is to know the certificate. So again, close these ones and simply click on any of them. Let me click the one that says certificate. Okay, so I click the one that says certificate. Students, while we are doing this, there's something very important I forgot to mention. Did anybody notice the time? Do you understand the time? We need to make the time something we can understand. The time is very important. So we have to go and change the time. Sorry, I should have done that earlier. We need to have a proper time. So go to edit, go to preferences, yes, that's what I'm looking for. So the time I want to see should be in seconds, not this. I forgot how
It's in
preferences. So edit preferences. Here is the column. On that column. No.
It's there.
Yeah, I can't see.
Oh, second one.
No, it's not that one. So
There is time before we go to preferences.
let me just close this. So there's something that says time display or time format, very easy like that. Okay, sorry, look at it here. I need something simple. So go to, I think it's view, then time display format. And what you want to see is UTC time. Okay, let's try the one with date and time. So UTC date and time, or time of day. I don't think that's the one I want to use. Let me just see what. Okay, they didn't do that. So what I want to do, I have my own material prepared. I want to see the time in seconds only. I don't want to see everything.
In the view, you can edit if you only want to see seconds.
Yeah, no, I'm trying to. What we want to see is only in seconds here. But I don't want to see the date. Okay, this is what I wanted. Okay. So now we have the time as seconds. This is so important because if somebody is talking to Sayid and they spend 10 seconds, what are they discussing? If they spend 1 second, again, we can know what's going on. So the time, because at a point we can capture two people conversation and we'll see how long they spend to communicate and so. So we need to see the time in seconds, just like this, to help us understand the distance between when the server sends hello and receive hello, which I will use later. Okay, better now. So our focus is on security, on a certificate. So on the certificate, so I want to go and click on the small button there, and then if I open that, I want to go to certificates, and under certificates, I want to go to any of them. So we have 2 certificates here. So I can try the first one, and you will see signed certificate. So open the signed certificate, and if you look down, you will see issuer Arodian sequence. So click on the issuer, and you can see this one again, and now we have it. Okay, so I will go back one more time. Did everybody follow me? Let me go back, or you got it? So, because what we want to see is where the certificate came from, if it's valid or not. So if I open the transport layer security, I go to the handshake, and I go to the certificate itself. So there are two different ones. And then for certificate, I go to the issuer. So you have the signed certificate, and then the issuer. And what do you notice, students? What do you see here? The country. In this case, what country? USA. The state or province, Washington. The locality. And you can see if it's valid or invalid. So this is how the website can know if certificate being used is valid or not, and from where it came from. So what can we do? We can also apply our filter again to see when certificate is valid or not. But I don't want to plug my color space. So students, we can always check to know about certificate. All of these things are the real life data that have been sent from the server to the client. Because in most cases, we need to trust certificate also. We said that authentication works in both ways. It's not always the client that try to verify themselves to the server, but sometimes, or in most cases, the server should also be trusted by us. Okay, so that's how you can find, and again you can see here, the algorithm used is SHA-256 with ROSA encryption. And you can learn a lot about what happens behind the scenes. What else can you see? Look at this one, the key exchange. And the key exchange here, they use the Diffie-Hellman algorithm. So this way, you can go and find things about the key and certificate. Okay, so what they wanted us to do is to find the PC name, which we have already found. But instead of doing this, I've prepared different filters for you. So mostly, I don't follow what Salford provides, but they're mostly very elementary and basic. So I prepared other filters that you can use to get most of those things. And the first one, I had a few things. The whole idea of what you're doing is about incident response. What is incident? It means that any event that alters the CIA triad, confidentiality, integrity, availability. So if there's any malicious activity within this network, we can find it because it impairs the performance of the same triad. So what we're looking for is when an event happened, which means the timestamp is very important. Apart from that, who was the person that did it and to whom? So it's from where to where, but there's always the source and destination. And finally, what did they do? So if we answer these three questions, we can always catch the bad guys, and in case we go to a court of law, we can prove without reasonable doubt that at a particular time, you, because of your IP address, your MAC address, your host name, and all sorts of things, and your PC, you enter this website and you downloaded this or deleted something. That is what we call when, who, and what. So that's about incidents. So far, we filtered the HTTP request and here is the term we're looking for. Okay, apart from that, we can try to filter when we combine both the request and the server name, and we have a much bigger response. So the next filter, I simply combine when you have the host name. Because students, remember that the first thing we did, we found the name of the host. We used the filter request, HTTP request, to make a column for the host name. And then we did one more to make another one for the server name. Now, if I use all means I combine those two filters, and my results here will reduce to less than 85,000. So let's see. Please, Mohammed, he just came, he's not in the class today. So what do we have? So now we have both the hello message, and if you look, here's my host name. I didn't save the host name. I'm missing my host name. Anybody will have the host name. So in one of the columns, we should have the host name we created. Let me try one more time with the host name. So give me 1 second. I need one more column for host name only. Okay, so the one that told us is skill, so apply as filter already exists. So where is it? Okay, so the host name before server name. Okay. Or TLS dot okay, let me find my host name. Okay, my host. Okay, so the host cannot produce because there are not many host names. So we can use a different tool to find more host names. So by doing this, we combine two filters. You can do or, you can do and. There are different ways to use logic to try to reduce your result. So that's the next filter. The next one I plan is a different one to find the host. And this protocol is called the bootstrap protocol, which means if you have the bootstrap, which I don't think is working here, if we capture live traffic right now, we can find the bootstrap. But for this particular capture, we don't have the bootstrap, but you can try. So the protocol is boot P. So if you type boot P, nothing comes out. It does not give us an error, but there's no package without protocol. We can try bootstrap. This one is boot parameters. Again, nothing is captured here. But if we had anything, this protocol would have given us more host names than the previous HTTP request. So in case you have a capture, try boot P protocol, and the same method, go to the left and you can find host names, which take us to the one that can give us other information. So the other one is DHCP. Again, DHCP server is one for auto configuration, and you can use that to get more about host names again. Because every machine that comes to PUB will send a DHCP discover message, and then from there, Wireshark will capture the name of the laptop. That's how we can get all those details. Okay, so those two are useful if they're not working here, and that's because no packet here. The next one I use is called NetBIOS, which is basic input output, and the protocol is called NBNB. This one is working, so NBNB, all these ones, NB, NetBIOS. Okay. So NetBIOS is a protocol that we use to locate names of devices. And from NetBIOS, now we found a few more names. Even without doing those details, I've seen things like Nairobi. So if I click on just one, okay, if I click on the top one of the packets and look at the protocol now, NetBIOS. If you look at the protocol, go to queries, go to this one, and you can see the name now. So every computer name will now be put under this. So what can we do? Again, we can right click on it and we can apply as column. And if we scroll to the right, you can see the name of the machines being translated. So remember, I tried to use Bootstrap. There was nothing, but it wasn't used. I used DHCP, nothing. I used NetBIOS and I found some name. But that's not all, because I found the name of a lady from Nigeria called Naomi in this document. So we can see that even though you think these are all the names, it's not enough. So we can try other protocols to see some names again. Anybody have the ones with this one, the NetBIOS? Okay. So now we have the names of people, and you can see Naomi's workstation. And what can we learn? Look at the IP address of Naomi. So it means that Naomi is time, somebody write it down for us. Just later I'll see the IP address. Is it, what's it called? Not Naomi, Nairobi, sorry. So 10 dot, what's the IP address? 7 point. Huh? No. This is the right address, 101. Students, this can be an IP address. 101. Okay. Anybody remember the first IP we saw during the class? This was the first IP address we saw. So this particular workstation, now we know who is maybe doing something. So we are going to build a profile with time. Okay. So now we know Nairobi. So what can we do? We can come here. So far, we have the host, we have server, and we have other hosts again. And we can build a picture later. So the next thing I want to discuss, so the next one I want to use is a filter called Kerberos. So Kerberos is also used to find information about user. Again, it's very simple. If you do KEP, it gives you the auto spell. And whenever the color changes to green, you know you have the right protocol. The next protocol I want to use is the Kerberos protocol. Now, if we filter based on Kerberos, we have different results again. So what I will do, I will click on any one of them. So if I click on this one, sorry, I want to focus on the ones with AS request. So click the ones that have AS request. Remember, AS is autonomous systems. So if you click on AS request, that's when you have the Kerberos to the left. So if you click this one that says bind, you have a lightweight directory protocol. I want to focus more on the one with Kerberos because I filtered for Kerberos. So if I make the Kerberos smaller and go to the AS request, the second one, make it bigger, and then go to the body, and you can see the C name. C name, if you remember from last year, it means an alias to something. For example, a nickname. So if I click on the C name, it gives me the name, that the name is gooddreams.net. Anybody here with me? So the C name, one is just the C name. Later we can find the C name string. So I will go back. So I selected anyone with AS request or any of these ones. And from the Kerberos, you can see this is for reply. And we're going for the C name, the alias, and then C name string. And then you can see that the C name is Nairobi PC. So this is much better, right? So let me click on this, and what do we do, students? Apply as column. Well done. So if we do this, and we come back, we now have a different column now. So you can come back here and see Nairobi, Nairobi, Nairobi. And if you filter this one, what do we see now? Anybody have Naomi Okonkwo, which I know is a Nigerian like me? 100% Nigerian name. Anybody have the Naomi Okonkwo?
Yes.
Now we're building a picture. We found Nairobi, which means Nairobi is involved, and now we found Naomi. What is Naomi's IP address? Let's write it down. So this is Nairobi. What's Naomi's IP address? So just move to the left, and you can even see source IP. This is MAC address, the next layer. Okay, I didn't make it open. So just scroll, and you can see, okay, it should be here.
10, 7, 10, 7.
So look now, so what is happening? Remember this IP address. Naomi and Nairobi, they are communicating. So something's going on between two of them. So 10.7.10.7. And this is Naomi. Okay, so now we have concrete evidence about who and who are communicating, because we've seen lots of Nairobi. Without filters, we can't know all these things. And you can't be a one-trick wonder. You can't just say, I know bootstrap protocol. That's why I give different protocols to help us. But if I filtered only based on DHCP, I would think no communication going on. But I went further to find out what happens under the bonnet. Okay, and students, remember a nonce. A nonce is something that's not repeatable. For example, like a one-time password. And they mostly send a nonce. Look at the C name, Naomi here. All right, so far, we've been able to establish that Naomi and Nairobi are communicating. The next thing I want to do is to try to see if there's an email communication, an FTP, an IRC traffic, and finally a file transfer. Among all these different ones, the most deadly one is the IRC traffic. All of you are Gen Z, you are young people. When we are coming up, this is called Internet Relay Chat. It's like a group chat where you can go and join and you can chat. And in doing that, you can send message for everybody. It's like a chat room. Now, it's used for magical activities because somebody can turn them to it's not DDoS, I forgot the attack, we can use, I will remember, and they will send traffic to different people. And each of us become like a zombie for the attacker. Huh? Botnet, thank you. So this is used for botnet today. So if you come across anything around this in the packet filter, botnet is going on there. So what was planned for was for group chat, because not advanced today. In the olden days, we are not very smart. We used to have a chat room, you go there and you chat. Sports, you go to the same room. Now it's more separated. And people have taken advantage of this. So this is a problem. If there's any file transfer, again, we need to monitor the file transfer and see what's happening. You know FTP and email. So for the email, you're going to filter SMTP, the mail server. We can do FTP, we have data, and we also have that one, and then IRC and file transfer FTP again. So let's see what's happening there. So if there's any email communication, we can filter by those ones. And we just follow TCP string. So what I will do again, I will close my previous filter, and now SMTP is the mail server. Okay, in our own capture, there's no email, so it's fine. So maybe there's no email communication, I close it. Let me try FTP. Okay, no FTP. Let me try IRC. No IRC. So we are trying to check or tick every box to be sure that we don't have all these things. What else am I missing? Nobody remember DNS. So let's look at our good old friend, DNS. DNS is the most underrated map on the internet. Without DNS, no internet. So the most important protocol to me is DNS, because all our requests in and out DNS. And I kept this because I know that with DNS filter, I can make a simple look students. What do you see? Who and who are talking? So the DNS is the one that will give us who and who are talking. And you can see that DNS, all the requests, the response, everything is from Nairobi and Naomi and vice versa. And every website they request, whatever they do, we can then go and see all those different things. In most cases, if I'm doing this, I won't do like this. I can take other shortcuts. So I will come back to DNS, but how can I know what's going on? Let's take 10 minutes break before we continue.